Good morning and welcome to the second in a series of 3 winter roundtables with a focus on partnerships enabling innovations in sustainability, co-hosted by Action Innovation Network and the University of Massachusetts Lowell's Innovation Hub. I'm Joan Popolo, Executive Director at Action Innovation Network. And for those of you who don't know about our organization, Action is a nonprofit association of technology business incubators located in the New England region. And our members support emerging companies with technologies in the life sciences, climate tech, sustainability, advanced materials, robotics, blue tech, aerospace, and agrotech. Together with our co-organizer, UMass Lowell's Innovation Hub, an incubator supporting sustainability startups, we saw an opportunity to provide a forum to bridge the areas of medtech, healthcare, and sustainability, sectors highly represented within our network. Our winter roundtables are organized to convene interested stakeholders to educate and share information on the challenges and advances in generating solutions for a more circular and sustainable use of plastics and thereby decrease their waste burden. Today, we highlight 3 speakers within the innovation ecosystem to engage in a discussion on how their research, technologies, business strategies, and partnerships have helped them to make an impact on more sustainable plastics. We welcome questions from attendees. So please, if you have questions, enter them in the Q&A box, and we will address these with our speakers at the end of the conversation. This webinar is being recorded. As each speaker begins their presentations, they will provide a brief personal introduction, and we will leave most of the time for the discussion among the presenters about the important work they are doing to advance sustainable plastics recycling. I'll begin by introducing our roundtable facilitator, Dr. Grace Chen, Associate Professor of Plastics Engineering at the University of Massachusetts at Lowell. Dr. Chen has special interests in plastics recycling, biodegradable polymers, microplastics, safer solvent and chemicals, biomass conversion, and the life cycle assessment. So with that, I'll hand over to Dr. Chen.
Yes, thank you very much, Joanne, for the introduction. Again, my name is Grace Chen. It's my great honor to moderate today's discussion. To start with, I would like to very briefly talk about what my group is doing, mainly focuses on the current status of coal, specifically focusing on the plastic waste from the medical industry perspective. So let me go to the presentation mode. Let's see if you see the right slide. So can everyone see my slide in the presentation mode? Okay. So as you can see, the title today is to talk about advanced recycling of plastic waste. And I have a few slides to highlight some statistics in the health industry. To start with, I would like to talk about what my group is working on and some ongoing research program in our Plastics and Environment Research Lab. So as Joanne highlighted earlier, we study a variety of advanced recycling technologies. So far, we have developed several chemolysis reactions to construct polyesters such as PET, polycarbonate. We also are interested to design and formulate safer solvents so that we can reclaim the polymer structure back when possible. We also have several projects developing hydrothermal technologies. This is mostly to deconstruct very complicated, challenging to recycle plastic waste, such as multi-layer films used in the biomedical industries, or multi-layer films used in the food industries, where mechanical recycling will be challenging. I also collaborated with other colleagues here at our department at UMass Lowell to explore how we can make mechanical recycling more efficient, or how mechanical recycling can facilitate advanced chemical recycling. On the other hand, we also hope to address these plastic sustainability issues from the material design point of view, where we can incorporate and use more sustainable materials, such as biodegradable, compostable materials. Microplastic is also another topic that may emerge from the recycling process or the biodegradation process. So we also study that with the hope that we can avoid producing microplastic particles in the future. And when possible, life cycle analysis as well as the techno-economic analysis tools will be leveraged. So that will help us identify the research gap, the R&D gap that should be prioritized for the future research. Oops. So I probably over prepared a slide. I don't think we'll go over every slide here, but I would like to talk about the status quo of the plastic recycling. And I also want to show like 2 slides regarding the healthcare waste management. And I'll highlight some advanced recycling methods that would hopefully pave the foundation for Connor and Young to talk about their respective technologies. So from this figure, obviously you can see that to date, we have produced a large quantity of plastics. And this is almost like an exponential growth since plastics has been industrially produced in 1950-ish. And if the current trend doesn't stop, which reflects in the green line here, the recycled plastic waste will remain in a very small quantity. And because plastics, they degrade very, very slowly. When we design it, we were designing it so that it can be very robust, durable, affordable, and ultimately it also becomes the current plastic waste accumulation issue. If we take a careful look in the plastic waste we generated so far, we realize, and that's reflected in a pie chart here. Maybe I should change to the highlight. You can see that the majority of what we produced is polyolefins, including polyethylene, polypropylenes. These are very difficult to be broken down, to be deconstructed, followed by PET and PS. All of this majority are used in packaging field, no matter it's for healthcare packaging, food packaging, consumer goods packaging. And just when I was invited to moderate this session, I was very excited because that kind of forced me to review the recent statistics. So this slide was extracted from the plastic plastic Europe fact report that they just released last year. So you can see that in the recent 5 years, the plastic production still keep going. I mean, a lot of the manufacturing and production is increased. However, I do see some hope there. You can see we start to have some chemically recycled plastics. The mechanical recycled product is increased slightly. So this deep blue bar here that represent products that are made of mechanically recycled content. So in general, I would consider this as a positive sign where more and more recycled plastic were being adopted. Either it's incentivized by the policy or pushed by the customer. So let's also reflect it in this pie chart. You can see under the circular category, we do have around almost 9.5% of the mechanically recycled content along with the bio-based, bio-attributed plastics. However, I also want to highlight this broken cycle of plastic recycling. Although this literature is a little bit old, but it still reflects quite what's going on like in today's technology. So the broken cycle here means, let's say we start from 100% of feedstock, only 2% of them can achieve the so-called closed loop recycling. This means, imagine I have a water bottle. I don't know if you can see this. Imagine I have a water bottle like this. Only 2% of them can be used again for the same purpose as a water bottle. And that is quite sad, to be honest. I really think we can do better, but probably I should point out what's going on is that, well, to start with, the recycling rate is low. So perhaps if we can increase the recycling rate, that would bring the opportunity to increase the rate of closed loop recycling. Beyond that, during the recycling process, and here mostly is mechanical recycling, I believe, we mostly end up downcycling. We also lost some in the mechanical recycling process. Some of them is inevitable, but some of them, I believe, as plastics engineer, we will be able to advance this in the future. Most importantly is we should reduce those leak into the environment. We definitely don't want that in the ocean, hurting the environment, hurting the animals, hurting all the creatures. We also would like to reduce the amount that goes to landfill. I mean, in total, this accounts for 72%. That's the majority here. So I just want to share, I want to talk about and why is that? Why the current recycling rate is so low? So here, these are some pictures I took with my colleague when we visit MRF, a material recycling facilities in New Hampshire a few years ago. And you can see that all the packaging here, they were recycled in a mixed streams. And I should probably give you a little bit more background information here. All these waste were collected from in collaboration with local hospital systems, and we asked them like specifically to collect non-hazardous plastic waste. So they are relatively clean, only been used for a few times, but still you can see they are collected as mixture. So a short takeaway here is that without sorting, downcycling would be inevitable. Another issue we encounter is multi-materials used in a multi-layer packaging film or packaging makes the current mechanical recycling challenging. So here, let's pay attention to this multi-layer structure here. You can, for example, imagine if I have a bag of potato chips. That bag is made of, yeah, actually I show them in the bottom here. These potato chip bags, typically they are made of 4 to 5 layers. From the exterior to the interior, they include PET, foil layer, polyethylene, sometimes nylon or EVOH, this kind of barrier layers. So this kind of multi-material and multi-layer structure also make recycling very difficult. But this also, in a way, we also consider this perhaps a new opportunity, allowing us to explore advanced separation method, or from the design point of view, perhaps when we design these multi-layer films, we should consider their end of life and make them more recyclable and separatable. So I really appreciate this slide. Again, this is extracted from Plastics Europe. from the report I just released last year. So you can see that comparing, imagine if we have a separate waste collection system in the US. I mean, they have it in Europe. So you can see that by doing that, the recycling rate is almost 50%. And this is 13 times higher than that was just collected in the mixed streams. And I mean, it makes sense once we separate them based on the materials, for example, the sorted plastics will have a much higher economic value. And therefore, I think in a way, they also incentivize industry or waste management industry or consumers in general to recycling. So in the next few slides, I would just want to highlight the status quo of healthcare waste, and then I'll highlight some advanced recycling methods, and then I would like to turn the stage to Connor and Yang. So I think this slide will set up the stage and the discussion for today. Believe it or not, and as reflected in this chart, the majority of the waste that collected or generated in health facilities, let's say, for example, hospitals, most of them are non-hazardous waste. You can see 85% in this pie chart accounts for packaging, cardboard, a little bit of food waste. We'll have a more detailed breakdown in the next slide. Only a relatively small amount of them is considered or categorized as hazardous waste. And of course, this should be incinerated. I believe that's how the hospital is doing these days for the hazardous waste. According to the current regulation, they must incinerate it. So this is a very interesting, very recent data. I think a group of researchers from MGH, Mass General Hospital, they were trying to quantify the waste on an inpatient medicine unit in a local hospital, I believe. So you can see this also match what I showed you earlier. The majority of this non-hazardous waste. Among them, plastics account for more than half. And we can see that the majority of them are some gowns, gloves, and trash bags. Food waste, actually, as I mentioned, is relatively small. And this waste these are just how much was generated in a very limited amount of time. So I could put a specific collection and experimental period layer. And keep in mind, this is during the COVID. So these numbers may be like more or less shifted in today's new norm. And I would encourage you to take a look of this article, this communication article, which is reflected how today's waste were generated in a healthcare environment. So if we don't address this, eventually we may encounter these microplastics issues. So these are just some microplastics particles, microplastic bead, microplastic fiber. They could generate it during the weathering, the degradation, if the plastic tragically leak into the environment. This is a real world, this is an example we had in our lab where we were collaborating with a group of Hawaiian researchers, and they provide us a bag of sample they collected in the Hawaiian beach. And these are the plastic particle we found in the sample. I mean, they're supposed to be a relatively isolated area, but we still see these micro and macroplastic particles. So how can we address this issue before they leak into the environment? And I think I would really love to give Connor and Young time. So I'm going to wrap up very quickly here. So this slide it highlights some ongoing and underdeveloped technologies. So obviously, landfill is what we are using now, including the incineration as well down here. And mechanical recycling is another method that is more commercially available, but I think we can do more. Whenever possible, we should try to mechanically recycle plastic back into plastic applications. Hopefully, it's not downcycle. Hopefully, it's upcycle or remain for similar purposes. When impossible, for example, when we have very dirty, multi-layer, multi-material structures, advanced recycling such as pyrolysis, chemolysis, I didn't list the hydrothermal liquefaction or hydrothermal technology here, where my group is studying. These are all potential technologies we can consider to leverage and to develop more. Another emerging method is the enzymatic biological conversion, where researchers are using fungi, enzymes, microbacteria to degrade biologically plastic waste in the environment. So I would like to pause here, and I would be happy to facilitate or answer any questions that the audience may have. But I think this is a good stop to transit to Connor. So with that, I would like to introduce Connor, our next speaker, to highlight and talk about his perspective.
Great. Thanks, Joan, for setting this up, and thanks, Dr. Chen, for teeing that up with some of the harder science, let's say, in some of the technologies that we're working on here. I'm going to take a slightly different approach from Grace, and then we'll tee it up for Jan. A few years ago, I had worked on a book project, basically updating and creating new content for something that had been written quite some time ago that was actually very much ahead of its time in terms of thinking about plastics and sustainability. But it was so fast moving during that time that the book was almost out of date. By the time it was printed, there were so many things happening in this space. So, I mean, with the possible exception of the organic chemistry sections, that hasn't changed, luckily for science. But I continue to grow and learn in this space. I'm now working to help companies navigate policy related to plastics materials and identify true sustainability strategies that align with their core business. The book provided some foundational support for that, but we'll examine plastics and sustainability and whether or not it's a contradiction in terms. So just to be a bit of a contrarian and get started on this, if your algorithms feed you the same information that I see when it comes to recycling and plastics, then you would think there's nothing else happening in the world. But one thing to keep in mind is that we have very big environmental challenges in the world, and they're not all related to plastics. It is important, and there's a lot of work going on. There's a lot of business opportunities, which is a good thing. But there's an awful lot of materials and energy spent in this world. For example, when we talk about new data centers that are required for generative AI, for mining Bitcoin, even a few years ago, it was shown that Bitcoin, if it were a country, its electrical consumption would be the equivalent of Malaysia or Sweden. And to confuse things even further than that, we talk about gold mining or iron ore mining, anything else like that. These are 50 times more expensive than Bitcoin mining. And that's before we talk about the very physical and very environmentally polluting byproducts of most types of mining. So this chart here is just for a little bit of true context in the sense that it's from a report called the Circularity Gap, and it's put out by a group called Platform for Accelerating the Circular Economy. They do issue it every year. I do highly recommend it. And the premise, as we probably know, is that the world is consuming more than it can replenish, therefore the circularity gap. And over 90% of all materials extracted and used are wasted. It's not just plastics. So let's talk a little bit about why we're on plastics then. I mean, efficiency is usually considered to be beneficial, but as Grace kind of hinted to there, My grandparents were born in 1920. Just a lot of people's grandparents, plastics weren't around. We have to keep in mind that the PET that we use for water bottles was really only patented and commercialized in the 1940s. And polypropylene and polyethylene, the olefins that came afterwards, were only in the 50s. So doing more with less is usually a good way to manage resources. But what happens when efficiency inspires increased use of an item? And that's what we see with plastic. So for those who are familiar with the energy world or energy efficiency, the Jevons paradox has been used to describe the phenomenon where a commodity is made more efficiently, but the demand for the item continues to rise, leading to increased consumption. And we've absolutely seen that with plastics. Essentially, we could say that its efficiency might even be its Achilles heel. So even the speed of packaging innovation and plastics production far outpaces the ability of our infrastructure to manage it as it stands today. But it is important to keep in mind that this really is only 70 years old, and it's going to take some time for us to get where we need to get. So let's talk about the scale of the challenge, right? I mean, it is big, it is all-encompassing, it's on everybody's mind. When we look at the PET specifically, and we'll talk about PET mostly because that's where Jan is focused as well, so this will help lead into his work. There's only 3,000 tons of new capacity expected to come online by 2025 to help with recycling infrastructure. The main takeaway from this slide, the 14,000 kilotons of new rPET capacity alone would be required to come online to meet global commitments made by bigger brands and bigger companies. And ICIS and some others, we'll go through some slides here, they have some good data on that. And moreover, the Recycling Partnership and other groups have identified in some reports that it would cost up to 17 billion in capital expenditures alone to quote unquote fix the recycling problem. But other studies have shown that the way to fund that is the challenge, right? This is not really a technical issue. This is very much an investment and business issue, although of course there are some challenges in multi-layer structures, as Dr. Chen pointed out there. But things like government grants and government investment are not always ideal because they tend to be one and done. And when we look at markets for the trading of some of these materials, especially recycled materials, there are no long-term contracts, or there are very few of them. And so the lack of long-term contracts make it a very risky business and make it difficult for people to secure and sustain material supply. So from the perspective of private business, it's kind of a risky investment. There's a lot of companies that seem to come and go in plastics recycling, primarily related to the commodity prices. And though we have seen some bolt-on acquisitions where people are investing in their own supply chain to ensure a steady supply of raw materials, that's not always a slam dunk either. In fact, this headline here is actually from Germany, which is a company we would think of having their act together when it comes to recycling. But even there in Europe, as we'll see later, they are struggling from some serious structural issues as well. That doesn't mean there aren't opportunities. There are new players emerging in various sectors, including in bio-based materials. So we'll take a look at that as well. But if it's so broken, as we see from so many of these headlines, to be so pessimistic, why are we still talking about it? If recycling is a failure and it doesn't work, then we should all just give up, right? Well, that's not really how it works. That's not really how it works in business. That's not really how it works in entrepreneurship. Recycling is very real. There's a lot of people that work in this sector. There's some very profitable business. And every pin on this particular map that's provided by the closed loop partners is a reclaimer or reprocessor of plastic. And this is just in the US primarily, right? There are some quibbles over recycling rates versus access rates. And that's mostly when we're talking about post-consumer, but post-industrial recycling is huge. I just heard the other day that Walmart, in fact, with about 45 or 4,800 stores, recycles more cardboard than the entire residential population of the United States. That's a lot of material. So even though we might quibble over post-industrial, post-consumer, this is an industry that ranges from 40 to 80 billion in economic value, depending on which estimates you use. So we can take a closer look at some of that as well. So there is good news here. I mean, the demand is increasing. People do want it. They can't quite get it. We need to figure out how to do that. This data here is provided by Wood Mackenzie, And some people may be familiar with the breakdown of PET. It's not all water bottles, right? A lot of this is polyester fiber. A lot of this is textiles. That's much more difficult than PET bottles in terms of recycling, specifically on that material. But many people are probably not as aware of this, just given the visibility of what we consider to be plastic or plastic waste. So according to other analysis, Pew Charitable Trust and System IQ in this case, 54% of plastic will be economically recyclable mechanically in high-income countries when we account for design for recycling, which is an interesting caveat. We might not get it in the slides, but the arrival of EPR legislation with specific requirements for design for recycling is going to help from a policy side there as well. But on the right side of the chart, we see that 20% of total plastic waste can be recycled via plastic to plastic chemical conversion. And there's a lot of heated debate about the terminology. It has changed even in the past couple of years. Jan will probably help us get into that in terms of what's considered chemical versus physical or molecular. And some people argue that waste to oil is not truly recycling. I think this is debatable. I think anything that displaces fossil fuel consumption is valid and should be discussed. And if it has a lower energy return on energy investment, that should absolutely be considered. Because even though we're in the early days of these technologies, it's not clear for all of them what will happen at scale. But this is a global market, and the law of competitive advantage still applies in PET specifically, even though we have these demand signals coming from the brands. We can't get enough of it in this country, so we do import. We import quite a bit of PET materials to meet some of these PCR content goals. We also export. We have a surplus in the United States in virgin resin, especially in HDPE. And we don't have time to get into it here, but the recent figures coming out of China in particular, in terms of their structural excess capacity, has very important ramifications for pricing globally, which affects business models in turn. So this data is an example of this provided by ICIS. Again, they offer excellent reporting in multiple sectors, including plastics recycling. They also do deep dives into PET scrap market dynamics, which is interesting for recycled content and the economics of businesses operating there as well. Their publications focus on both mechanical and advanced recycling, and we'll get a little bit more into those as well. And even when we talk about advanced or chemical recycling, there's been a couple of big headlines on there. This is big money that's going into this, and these are typically big companies that are offering to do that. Not for the faint of heart. That's partly because the challenges are well known. It is difficult. I did say that it's not necessarily a technical challenge, but we don't always want the perfect to be the enemy of the good when it comes to some of these technologies, because like all of them, people who are more focused on this can talk more about the second law of thermodynamics and what that really means. There are people who are skeptical of pyrolysis, for example, when it comes to managing plastics waste, especially hard to manage plastics waste. But there are many new investments going in that. Pyrolysis is a known quantity. It's not perfect, but certain polymers do much better in terms of yields, which is the biggest part of making sure that chemical recycling can become affordable and profitable. So this is a second ICS heat map focus on chemical recycling plants in the US and Europe, pre-commercial and commercial. They expect 9x growth, 9x growth in North America and 22x growth in Europe. But again, pyrolysis represents the lion's share of growth in both of those regions. But not everybody has over $1 billion down the back of their sofa to build world-class chemical recycling factories, right? So beyond the strategic investments from existing majors, there is a lot of activity in the startup space for recycling, which is exciting. It's perhaps a truism in modern media that negative news is more appealing or easier to doom scroll through negative stuff than positive stuff. But a closer look at the innovation in plastics recycling and bioplastics as well reveals a rich array of entrepreneurs and small companies who are working to solve difficult problems. The old adage is, find something that sucks and then go out and fix it, is still very true for recyclers and entrepreneurs operating in that space around the world. So one of the things I try to focus on with people is to zoom out a little bit and actually keep in mind what we're actually solving for, right? When we choose one metric over another, it risks creating some unintended consequences. But can we solve for both at the same time? Even Gartner of Magic Quadrant fame a couple of years ago predicted that companies would abandon plastic recycling goals in favor of reducing their overall carbon footprint. People don't post images of carbon savings. It's much easier to post image of stuff washed up on a beach. So that would presume that we might be solving for litter, potentially at the expense of GHG emissions. And I can report that at least one major brand has stated that they would eliminate plastic packaging specifically to focus on the carbon footprint of the product, which they were going to package in something like molded fiber, which is 3 to 4 times the carbon footprint of the package that they were replacing. So law of unintended consequences absolutely strikes there. So when we talk about carbon footprinting and we talk about the metrics for sustainability, what is the right one to use? And the footprint of materials can vary widely based on the approach used and the accounting methods employed and life cycle of plastics. I was fortunate enough to be in South Korea last year for part of the UN treaty discussions. And when the topic of LCA came up, the US delegation specifically preferred vaguer language on it to indicate that life cycle assessments are not universally accepted at the same level, right? There's much more data than there used to be. The ISO regulations around it are certainly helpful for standardization, but it's still not totally clear that this is what people will be using. But for example, in this one here, I mean, different studies assigned a number of different values to PET. And if you take those values into account, the ultimate carbon footprint of PET could range by 100%, depending on how it's made. And when we dig deeper into some of the work done by colleagues of mine in the Society of Plastics Engineers, not all recycled plastics are equal. In this case, virgin HDPE and virgin polypropylene have up to 70% lower CO2 equivalent than virgin PET. Recycled HDPE and propylene have 25% lower CO2 equivalent than rPET. And even further, 30% recycled of the olefins has the same CO2 equivalent as 73% of rPET. So by those data, it's always more beneficial to recycle the olefins, but that's just not the case, right? I mean, there are other material properties that come with different materials that make them appropriate for particular applications. Again, plastics are almost infinitely tunable, which again goes back to their Achilles heel, which is that they are so efficient and so easily made in such big quantities that they can solve a lot of problems for many different applications. Propylene in particular actually does very well in comparative life cycle assessments across materials, but the recycling numbers are quite woeful by one measure. But then again, the other side of the coin is it's a great opportunity for someone to come in and improve that. So the core of plastics and sustainability then, from my perspective, is the measurement of the impact of our material choices on the environment. If everything is equally important, then nothing is important. So if we take a quick look into the medical sector and life sciences, then given our location up here in the Boston, Cambridge ecosystem, there's a lot going on here, and I've just tried to summarize these things in a slightly different view. Some basic categories like packaging, medical devices themselves, and then the role of bio-based materials. In all cases, risk factors weigh very heavily in this sector compared to others. And to Dr. Chen's point there about what's actually considered to be biohazard versus not is maybe not so intuitive. Though that's a big number to represent recyclable, recoverable materials in that sector, as opposed to having everything go into a biohazard bag for fear of sterilization issues. So a very short case study here then on this. Medical grade plastics, for packaging at least, are a lot more expensive than they are non-medical uses of the same type of plastic, including PET. There are newer grades of PET are now emerging that offer the same protection and benefits of PETG, which has a bluish tint. And if you've seen like the Tyvek being peeled off different instruments in operating rooms and hospitals, that's typically a thermoform PETG package. But as we see, when California changed the rules in terms of what could be considered recyclable, that forced a shift, which again was not a market-driven shift necessarily. It was a policy-enforced shift, which we also see with a lot of rules and regulations come out of Brussels and Europe. Just to say that, you know, business opportunities can sometimes be the result of policy decisions. And not all developments are related to external plastic applications that we see. There's a tremendous amount of work being done around the world on how to harness the power of biopolymers for various life science applications, as quickly summarized here. This is an extract from a much bigger one. Groups that I work with, including Society of Plastics Engineers, Medical Plastics, European Medical Polymers, are great platforms to really dig into some of the science and hard work that's being done in these areas. So, but what does that mean for us going forward? It means there are a lot of opportunities at the nexus of plastics and sustainability. And there are many new companies and business models working to address the macro challenges. Some are focused on chemistry and technology business models, and the application of AI tools is certainly going to reveal some new opportunities as well. But solutions depend on the end market. There are lots of exemptions in medical and healthcare packaging, for example, but large converters and producers are still pursuing recyclable materials, including increased proportion of recycled content, despite the challenges that we see today. Things don't happen very quickly in these environments. You know, product development timelines are long and complex. They can take up to 2 years for study, lab testing, another 2 years for production and scale up, tooling, prototyping, capital equipment. So at the very top level of big existing companies, those programs can have to be well funded for a long period of time. Not so easy for the startups. But additional testing specific to medical and healthcare sectors include things like child resistance, elderly friendly packaging, stability testing, and these have extended periods for testing as well related to things like extractables or leachables. FDA plays a big role here, and they are clear about what types of recycled content is allowed or not, especially in OTC or pharma products. But bio-based or chemically recycled materials are approved for use. And when we talk about other business models, such as diversion or take-back systems for difficult to recycle materials that may even be thermosets, pyrolysis does seem to be an area of opportunity for landfill diversion, at least in that case. So that's it for me. I will turn it over to Jan and dig into what an actual entrepreneur does with his sleeves rolled up.
Thanks so much. Thanks so much for the kind intro to John hosting and Dr. Grace Chen, getting the big overview, and also Connor's really exciting knowledge of the space, like working a lot with industry players and policymakers and so forth. So yeah, let me share a little bit about myself and about Macrocycle. My name is Jan. I'm a chemical engineer by training, did a PhD at ETH Zurich, worked first in my science exploration on bioplastics, as we heard about just now. And developed a new technology around something called ring opening polymerization, realized that not only bio-based wastes can be turned into plastics, but also plastic waste can be utilized in that type of chemistry. And then took that chemistry along my academic journey to MIT, and then eventually spun out a company after all the entrepreneurship programs that are around the Boston, Cambridge, and MIT and Harvard and so forth area. Went through all the entrepreneurship programs, started pitching and seeing, is this not only a cool technology, but is there actually a need for in the marketplace, and can you get paid to do this? Because, you know, on the science side, you know, I've certainly come from a background where most of the merit is valued in how many papers are you publishing and how great is the science, but does this eventually make money, and is it cost effective, is rarely addressed. And so I think we're seeing more and more in the sciences, which of course was what Dr. Chen has, for example, alluded to, but that is on top of mind when we're starting a startup as well. So let me show a little bit about Macrocycle Technologies. Here we are. Let me share the slide. See if I can get this to full screen. All righty. I hope everybody can see this. And so Macrocycle, we're creating circular plastics with zero carbon emissions. And you see myself and my co-founder, Stuart, who I met at MIT in a sustainability class, and we've been running with Microcycle together since 2.5 years. So back to the story of plastics that we've now heard a lot about. I want to double down on the fact that we really have this love-hate relationship with plastics. So we kind of love the plastics when we go outdoor hiking, when we do sports, or we're gonna find a plushy, cute little toy for our children. Those many devices that and many items that we use every day are made from plastics because they're so versatile and so useful in a sense, as Connor highlighted. However, we really don't like and don't love the plastics when we see the bad influence that it could have on the environment, with 85% of all the plastics really not being recycled, and the plastics industry not the only polluter in the world, but certainly a significant industry in the world that causes environmental emissions that contribute to climate change. And so this is really, not only a big problem, a significant problem, but it's really also a big market opportunity, which is what you have to convince investors if you want to raise money for a new technology in a very complicated space. So we think there's a decent market opportunity to solve plastic and do profitable good at the same time. Obviously, big brands have made pledges to use more recycled plastic in their product to comply with regulation. However, they're all struggling to find enough recycled plastic on the market because either the quality isn't good enough or it's too expensive to do it. And so that's where we come in and try to solve these companies' pain points. And so as entrepreneurs, you have to be customer driven. You have to have a good technology, but really somebody needs to want it. And so we're speaking to these folks in the market and hearing that it's just not easy. Even if you wanted to use more recycled plastic, you can't find it. And why is that? Because mechanical recycling is today the main technology available, which is 99% of all recycling of PET bottles, let's say, today. And how that works is you basically just collect the plastic waste and then you sort out the bits and pieces that don't belong there mechanically. Sort of, metal detectors will strip out some, and then you have a density separation, something that floats in water, lighter plastics versus heavier plastics like PET with higher density. You just float, sink, separate them, and then you end up with a flake, ideally, and then you grind it and melt, extrude it back into a new polymer, or basically into a new pellet or into a new article, like a new bottle. However, you're always experiencing this this color increase, which the industry doesn't want. And also you can create small toxic volatile components that need to be stripped out as well. And so that is it can, if you have the right and quite expensive process, you can recycle some of the plastics, especially rigid plastics, mechanically. But for example, anything soft is typically rejected, and the machinery is simply not set up for it, and it can't handle anything that's not rigid. And so another problem that we heard about earlier is also the collection itself. Typically, we throw everything in the same bin here in the US, at least. And mostly it's single stream recycling, and all the plastics are thrown in together with cardboard and aluminum and so forth. And so that can also create problems because you have to basically separate everything again after it's being collected. And so I had in some of the talks that I gave, I had this questionnaire and did some quorums here. What do actually these recycling symbols mean that you find on some of the plastic items? And surprisingly, people have different opinions, and I can't do a quote here right now, but some of the results are shown here. People think that these numbers, they could mean how many times you can recycle something, or how many years it might take to degrade, or how tough the plastic is. But unfortunately, none of these things are true, or basically the only truth is that, first of all, the recycling symbol, the arrow as we now know it, is basically just a symbol that looks nice, but it doesn't have any meaning. It doesn't mean it is recycled. It can be, or it can be. It doesn't mean anything about recycling. It just looks nice. What really the number tells you is really the type of plastic, and specifically the chemistry of the plastic, what's behind it. And so you have to recognize that even though the plastics might all look similar, many people don't know that the chemical structure behind it is very different sometimes. Polyethylene terephthalate, polypropylene, polystyrene, different types of plastics. And so with mechanical recycling, unfortunately, we really don't really care about the chemistry. We process them in the same way. But new technologies like ours, with those, we're really starting to care about the chemistry behind the polymer. And so the other technologies that are out there currently being developed that we heard about, pyrolysis, enzymolysis, methanolysis, glycolysis, these are all technologies being proposed for plastic recycling. And the paradigm is always, because the word has lysis in it, it means breaking. So you're breaking things apart to basically derive the building blocks of plastic or even fuels. And so you're basically going back in the supply chain from the plastic that has been created once upon a time, and then you're feeding that monomer or the fuel that you derive from it back into the existing petrochemical supply chain, and then you have to build that oil or that monomer back up to large molecules, what polymers and plastics are, and you have to purify all of those as well to arrive at high quality. And so you can get to a high quality plastic with these more circular technologies. However, the question is always, how much energy does it take? How many emissions are you actually causing doing so? And how much better are you doing compared to fossil-based plastic? And so in the pyrolysis realm, it's certainly a potential technology for the future. However, the life cycle analysis is showing poor results for many technologies, not for all of them. So there's definitely research and development needed. And then it looks a little bit better for the plastic to monomer cases. But with macrocycle, we realized our customers, again, are struggling with those companies projecting relatively high prices for those recycled PETs in the future. And so with macrocycle, we're not doing any of the bragging. We can upgrade plastic waste and come out with a so-called virgin grade material without having to break the polymer down. So we're not doing the lysis. We're not breaking bonds, we're making bonds. And that's why we call our technology solvogenesis instead, because we're taking the plastic waste and then selectively we're converting the polymer chains in the waste into macrocyclic oligomers. That's why the company is called Macrocycle. And then we can purify them and then bring them back into the linear polymer chain, which is what the plastic is composed of. And so that allows us to do basically what others are doing, but in a much more effective and cheaper way. And here are some pictures from the lab and from our pilot reaction facility here in Cambridge, Mass. Next to MIT at the engine is where we're operating. And so we have plastic waste coming in. We're working with different partners, different suppliers of plastic waste and textile waste. We're stripping out the bad stuff, or not the bad stuff, but the stuff that is not PET. And then we go through a chain length upgrading process to improve the quality of the plastic. And then we're removing color as well. And these three process steps are what we're constantly improving on a daily basis. And we're working together with several customers to then test our material, our premium grade macrocycle PET that we're producing, to see how it works on our customers' machinery. And they will have certain requests of what the color or the chain length or the melting properties should look like. And so that's an exciting journey and highlights basically how, we as a startup may have a cool technology, but we really rely on good advisors, good customer inputs, good supplier feedback, and really learning about the entire supply chain to be able to provide something with value to the industry that can, help improve the environment and also, be profitable and be a successful business case. We do lifecycle analysis as well, internally and externally validated. Our current analysis shows that our energy demand is about 80% lower than fossil grade PET production. And our process is also not really using any extreme temperatures as some of the other techniques are requiring. And so we can electrify the entire process and therefore also derive a product that is 100% carbon free, or that's at least net carbon free. This is a bit how it looks like currently. As I mentioned, here at the engine in Cambridge, we're renting lab space. We have analytical equipment. We have reaction vessels on a small scale in the lab, in the fume hoods, and we have a pilot reactor on the ground floor where there's much more space for expansion. And so that's able to produce larger amounts of plastic and recycled PET so that we can work with customers really on product development and not only the lab sort of small scale testing. And that's what we're very excited about this year, to really bring a first or go towards a first bottle or textile on the market, hopefully maybe to be announced next year, to be determined. But lots of exciting things are happening on the entrepreneurship world. as a startup, every day you learn something new, and you're working with smart people to give you feedback. So that's a very exciting journey here. Our scaling plan involves going from the current capacity to basically a demo scale product with a customer, the first ever macrocycle plastic products seen on the shelf, and then ultimately building our first ever recycling plant and recycle tens of thousands of tons of plastic per year with our new technology. And finally, I want to finish with a recent picture from the lab where we're excited with the technical team to ship another batch to customers and be excited about something that we worked on hard in the lab creating, and then getting exciting and positive feedback from them was very rewarding. And so that's basically what we're doing day by day. And with that, I think I'm gonna stop here, stop sharing, and we can get into the discussion, and also, of course, hear from the audience. Grace, did you have a first kickoff question? And I don't know, maybe we should, I think we have half an hour left, so maybe we do 10 to 15 minutes, our questions, and then maybe the rest we go for the audience.
Right. I think while we are waiting for questions to be thrown in, we can kick off with some questions. First of all, thanks for both of your great presentations, sharing your insights in this important area. I heard that both of you mentioned that the demand for recycled PET is there, but we cannot deliver that, or the industry could not deliver that yet. I wonder if you can elaborate that a little bit, and maybe we can start from Connor and then followed by Young, because I do see Connor had a slide actually talking about and comparing the price between the virgin PET and the rPET. So I think that would be a great start to further elaborate this.
Yeah, for sure. I mean, this is what happens when you have a market economy, right? You like to be able to plan for some things, but planned economies don't typically end well. It has been proven that the costs associated. Well, let me go back a step. A colleague from the APR, the Association of Plastics Recycling, once gave me a little visual, a verbal visual that I thought was very helpful. When you think about how the virgin polymers are produced, it's essentially one very large diameter pipe. And when you think about getting recycled material, you have a 50-ton truck that's driving 5 miles an hour and stopping every 30 seconds to pick up 96 gallons of mixed recyclables. So it's kind of not fair in terms of how the costs are set up to do that. And as Jan pointed out, we've essentially outsourced a lot of that work to the MRFs, to the material recovery facilities, right? If you stick everything in one bin, it's up to them to sort it. And they will only sort it insofar as they can get a valuable commodity to sell out the other side. And for the most part, in North America, the most valuable commodities are PET, number one, and number two, HDPE. Even though the other materials do have value, calorifically or energetically in other environments, but the markets aren't there for them. And so that's probably the single biggest thing. And then, of course, because it is a global market and we do trade, there are a lot of countries around the world where they collect materials more efficiently and more effectively and don't require the costs associated with sorting that we do. That's why we see so much material coming in from other parts of the world, Southeast Asia and China, particularly under the West Coast. And so those costs then certainly influence what people are going to choose when they come to buy, which then gets back to why we don't have long-term contracts. People don't want to get locked in and end up paying over the odds for a supply of material if they know they can be undercut by somebody who's on a spot market and buying it at a lower price at any given point in time. So it's not easy. It's definitely a paradox, I would say, for people trying to operate here in North America with recycled materials.
Yeah, and maybe I can add two things. So obviously the quality is one issue, and the collection is the other issue. The quality which is, as Connor mentioned, you rely on the established mechanical process to separate out things, and they simply are not set up to, or not yet, to deal with films or deal with textiles. That is just basically a technology problem where you need innovation from universities, from big companies, small companies, all the like, ideally to overcome that technical challenge. And then there needs to be, however, enough pull in the market that people are willing to pay for it. So that's on our, let's say, customer side, on the brand side. Are they making pledges to recycle plastic, or to use recycled plastic? Why are they doing that? Is it regulation that is pressuring them to do so, or is it their customer demand to actually, want recycled and want more sustainable technology? And both are not perfect, right? So you can't rely on the customer, voting with a wallet. It doesn't always work. People buy textiles and beautiful, shiny things left and right, and cannot necessarily care. And regulation is stronger in Europe, let's say, less so in the US, and other places, to use recycled quantities. And regulation seems to be a strong driver if it is in place, but you can't rely on it coming online. So as a startup, for example, investors are asking, okay, is this business model viable? Will people want recycled plastic in the future or not? Are people actually going to care? And so we can typically not say, the regulation will come and people will recycle more. It's not certain. So really, the only thing that works in life is price and cost, right? So you have to effectively be cheaper. And I think many other, and some people call it the first wave of recycling, the second wave of recycling. So many new technologies have sort of assumed there would always be a green premium and you would be able to charge more for something sustainable. And that no longer seems to be the case. Again, also potentially politically, support can drop and regulation, you can't rely on it. So really you have to at least be able to say you may be competitive in price long term. And so that trickles maybe down, hopefully, to collection, because in many places in the US, for example, there's no collection of plastic waste. That's why the recycling rate is 30%, or so, because many places in the US there's no bin, because a municipality will choose a landfiller that is charging less money than a recycler, a MRF. And so unless the MRFs can make more money by selling recycled material and there's more market pull, or it's cheap enough to recycle, they won't collect it, right? Or they won't be able to lower their prices. And so really the entire supply chain, from the waste generation to the collection, to the recycling, to the manufacturing of new packaging, to the brands, everybody sort of needs to look at it and support it. And we're hopeful that if you have recycling technology that is energy efficient and creates high margin recycled plastic and recycled products, then you're able to pay more for the waste being collected. And then you can hopefully collect more in the future.
Yeah, thank you for sharing the thoughts. Indeed, I think I was told a long time ago when I started this research area, in the end of the day, plastic recycling is a business. And business has to, if we want business to work, it has to make money or make profits down the road. And in a way, plastic recycling is also, or any kind of waste management to start with, is a low margin industry. So that's why I think being aware of these issues, for example, like Yang, what you mentioned, perhaps we can consider increasing the collection thing. Even just doing that could boost the PT recycle collection rate. So I believe you both also mentioned the effect of regulation or EPR, and perhaps now is a good point. I don't think either of us mention or define what is EPR. So perhaps can we take a step back and talk about first, what is EPR, and has it been enforced I believe it's only being executed in certain states in the US so far, but I think the audience would appreciate to know and hear from your thoughts about this.
Yeah, I mean, maybe I can. I'm still. I mean, I think Connor will know more about this. Me as a plastic entrepreneur, we need to get familiar with it, and there's different models of EPR, but extended producer responsibility, what EPR stands for, is um, the idea that you produce a material or you produce plastic, and you inherently pay a fee that goes into recycling efforts and pays for them and subsidizes effectively the collection, which is why in Germany, where I'm from originally, we have the green dot system. And so everybody who produces plastic pays into that and basically subsidizes with, I hear numbers from 300 to $400 per ton go into collection. And that is what enables a lot of collection. Without that subsidy, it wouldn't be feasible. And so I could see that in the US, because it is not there, basically, or it's now coming, being discussed in a few states like I think Maine and so forth. It's too expensive basically to collect waste in an efficient manner. And then I think there's an idea that you can avoid that fee by actually investing yourself in make it more recyclable in the first place, because there's a whole lot to be said about the design for recycling, right? So I think both you guys had on your slides, there's these different, like a whole host of different materials, but basically only pure PET, pure HDP, and pure polypropylene are actually being looked at from the current mechanical recycling infrastructure. But we have 1,000 different polymers and plastics that, or let's say hundreds at least, that are very slightly different but don't fit exactly into the stream. And if you have a multi-layer material, or even if you have textile, it's not designed for the existing recycling. And so I think if people, let's say, it could incentivize brands to design for recycling more, and then avoid those fines and fees potentially. Connor?
Yeah, I mean, EPR has been around for a while, right? I mean, we're talking about it. We're talking about packaging and not only plastics either, by the way. Like the EPR proposals that are coming in North America and in Europe with the plastics packaging waste reduction are also related to other substrates like glass and aluminum and paper and molded fiber and so on. But EPR has been around for quite some time for paint, for car batteries, for other difficult to handle materials. Um, again, the tension between market economics. If there's a market failure, and the social good or those costs are externalized onto society that has to deal with it through pollution cleanup or taxes for running different types of facilities. EPR is a method to fund it. In Oregon, for example, Oregon's one of the first ones that's introduced EPR rules in the US for packaging specifically, but it's actually, the official name is the Recycling Modernization Act, which is actually a very fair name. You need to collect money in order to make this system more efficient to deal with materials that didn't exist when MRFs were first built. The vast majority of these recovery facilities were built in, when we were reading a lot more newspapers, and there's a lot fewer of those around today. And so having the ability to use different mechanisms to fund it, EPR is not perfect. There's some people who really don't like it. There are a lot of people who fought it for a long time, which kind of delayed some of the action. But it is coming, and it is going to affect how people think about what they design, which materials they use, which combination of materials they use. And as Jan pointed out, there will be, it's called eco-modulation, which is the ability to either receive a bonus in forms of fines or fees being reduced, or a malus or penalty. If you put a product on the market that is more difficult or unrecyclable, you will actually pay a higher fee. So the incentives are set to make things simpler, right? Use more highly recycled material like number one PET, or move to mono material structures that don't require too much effort or cost at the recycling center. So simplify, simplify, simplify. That does have the risk then of everything looking the same, which marketers don't necessarily like. If we walked into a Target or a Walmart and you saw everything, gray and mono material, it wouldn't be as fun for the marketers. So there's definitely some inherent tension there. But the these rules are coming. In fact, in the US, there's something like 131 laws in 33 states covering 265 million people even today. And that's before we get into the big all-encompassing rules that are now being discussed, like SB 54 in California, for example. So those are all in play, and they are coming, and they will be here to stay, I think.
Yeah, thank you for sharing the thoughts. I think that's in a way, of course, EPR will, or any kind of regulation would incentivize, but hopefully you would also urge the design of change down the road. Before we move back to Joanne and to collect the audience question and things like that, I think perhaps we can conclude the discussion here with um, any of your thoughts or any of the final take-home message you would like to share with the audience. Um, and Connor, actually, I would love to hear your thoughts about the plastic treaty you mentioned earlier. I know we didn't even reach an agreement during the last round of discussion, the INC 5, and I don't know if there will be an INC 6 hosted by United Nations. But I think perhaps we can use the last few minutes to wrap up and then share the thoughts for the future. How can we make it better?
Yeah, well, I mean, there will be INC 5.2, which will happen in the second half of this year. They're still determining where it's going to be held. Um, you know, seeing the United Nations up close, or at least this division of it, was really impressive. I mean, you really have to put into context what it takes to get that many people from every country in the world, all operating in English in legalese. It's very impressive to see people from all over the world where English is not their first language, hashing out details like where the placement of commas go in treaty language, So it's a very, very different, highly specialized, highly skilled set of people going there. So that's number one, sort of at the mechanical level of how it works. At the broader level, the consensus was not uniform, and the United States and other the United States find itself on the same side of the table as people that wouldn't normally be on the same side of the table with, partly because of our surplus and our big competitive advantage in resin production. There was toward the end an emerging consensus of closer to 80 plus countries that were willing to agree on some language, but it was not uniform. So where they've left it is any treaty better than none, or will people walk away from a bad treaty? The tension between national plans versus international binding rules was always open. My sense is that we're going to have to rely on national rules because the Indonesian infrastructure is not the same as Germany's, and so you can't expect to have a one-size-fits-all type of approach to this. So it's going to take a little bit more time. I suspect some things may be banned, like problematic materials. They may be able to narrowly focus on some things that will have to be wound down. But I also think they maybe expanded the treaty scope a little bit bigger than it needed to be, and that led to some of the fissures that emerged. There are many UN agreements like Montreal Protocol, Stockholm Convention, Minamoto, that deal with elements of chemicals in particular. So there's a lot of discussion about the use of chemicals in plastics, but a lot of them are regulated elsewhere. And so I think that created some confusion and maybe led to, one of the bigger reasons why they couldn't find full agreement. But they will get back together. I'm hoping to be able to attend the second half of this year, and then we'll see what happens then.
And maybe as a take-home message then from my side, I would say, on a personal level, keep recycling and demanding recycling, and that in your area, more recycling will come online from your sort of mayors and local peers. And if you happen to work in a company that uses plastics or that has an interest in plastics in the greatest sense, urge them or the leadership potentially to support startups like ours. If there's money to be spent on marketing campaigns, you can also spend that money actually supporting startups which need the money desperately to make great new technologies happen, like us. And so we found, getting money to do what we want to do is definitely not easy in this space of plastic. And we've found, luckily, partners that are willing to support us, but we need more. So always excited to hear from folks that want to learn more about our technology and do something good in the world by supporting a startup. And there's, of course, also others. Thank you.
Thank you, Jan. So Joanne, I'll turn back to you. I did see there's one question just come in. So
Yeah, there is a question. I want to say thank you to all the presenters so far. There's a fire hose of information here for anyone listening in, but let's address this question that's come in. Given the Massachusetts EPR Commission's report that will not be concluded until 2026, what would be the top 1 or 2 near-term investments you'd like to see from the state to drive forward improved sustainable practices? Anyone can take that.
Yeah, I'll go first because I'm actually on my town's committee, the Climate Action Net Zero Committee, where I live in Plymouth, and this is a point of discussion. I would say that the biggest thing we can do in the meantime is really focus on organics, separating organics, collecting organics that may not be reliant on any EPR rules. Organics are still the biggest contributor to emissions in landfills, and there's an awful lot of valuable organic material that's simply going to waste that if it was diverted into composting in other areas would be extremely valuable. So I think that's one big area that we could focus on right now.
Yeah, from my side, I may be slightly biased, but I do think that investment in startups could be a very good thing. I mean, Massachusetts is, for example, great. We have the Massachusetts Clean Energy Center. We won a grant from them, and there's other agencies and resources available to also universities. UMass Lowell also obviously is much of the exciting plastic recycling and plastic processing equipment at UMass Lowell has been funded through state or federal funding. Or industry partnerships. And so, yeah, I think in Massachusetts, I mean, it's one of the richest states in the states, and is very resilient and has grown this wealth through a good amount of investment in research, development, and innovation, and being a leading hub in innovation. So, continue to invest more in innovation, including startups that can lead to breakthroughs that come from Massachusetts.
And one thing I can add on is to prepare that, although it's not concluded yet, but one thing we can do now is to do some to explore what can be, for example, alternative materials. Like I think Connor mentioned the so-called recyclable material, which means they are made of the same material and replace the current multi-layer, multi-material structure used in the packaging. Or like Yang mentioned, explore the technologies that can deconstruct the polymer back into their monomer state, and which can be resynthesized again to form new polymers. Just to have some technologies in the parking lot in case the EPI is finalized and really being enforced. I do think that would be a good strategy to prepare for the future.
I have one question that I'd like to pose, and I always think of waste in many instances is a health issue. And I think with more and more reports that we're seeing in the literature or in the public about microplastics, which Dr. Chen had mentioned early on in her opening statements, microplastics embedded into our bodies, right? And they're finding them in the brain, and they're finding them in almost all of the organs, and including plaque in our arteries. So even though there is no relation yet established on is that causing any harm to our bodies, it certainly raises an alarm of some kind. Do you think, so my question is, do you think that the more that the consumers or people hear about this and become more concerned? I'm certainly noting that the medical community is becoming more concerned. Do you think there will be a groundswell from the bottom up for, well, at least, recognizing that this is a maybe potential hazard to our own health? And will that drive more activity on the recycling side? It's just awareness of plastics in our environment. Do you think this will help the industry in any way?
My perspective, I definitely do think so. And it relates a little bit similar to the climate change discussion. And that is also related now to the change in administration here in the US. The narrative is shifting. And so seeing climate change and seeing plastic pollution, not, let's say, not only in the way of, okay, we're also warming the planet, but really seeing it as a health problem. Like it gets more difficult to live here. I think is it should not be forgotten, and it definitely can potentially, convince people who were not convinced before, and raise a different perspective. And in the plastics case specifically, I mean, as we all said, I mean, we like plastics are fantastic materials as long as they're produced in the right way and as long as they're not ending up in the ocean and on our plate, that we're eating them. And so, yes, I would agree. We should definitely, we shouldn't overhype and just, blatantly or just like, I mean, there's a bit of a hype around the microplastics and we have to still understand them. But certainly we should say, hey, plastics don't belong in the ocean. We need to do much better. It could be a health problem. And so we should definitely do everything to avoid it and therefore invest in recycling from the perspective of health and not just from a perspective of cost or and I think, Connor, you raised a great point earlier saying, some people say, okay, EPR, the cost on the brand from regulation will be passed down to the consumer and make things more expensive for the consumer. But that's a cost on the consumer. It is a cost, but society and the consumer also has a cost to their health if these laws are not in place and recycling is not happening. And so the sort of environmental and health cost, which is much harder to quantify, is real and people are not realizing it. And so investing in better technology, better recycling can definitely improve your health.
Yeah, I mean, human health is certainly, it gets people's attention, right? And some of these studies you mentioned, Joan, are certainly focusing the mind. I think it is important, as Jan sort of alluded to there. We need to keep this in perspective, though, right? The two biggest contributors to microplastics are tire abrasion on roads and synthetic textiles from your washing machine. Picking a water bottle up off a beach isn't going to solve that, right? And so we need to keep in mind that what are we arguing against here? I mean, we're talking about modernity in general and threats to human health from all over, including the food that we put in our bodies, and many of the materials that are ingested that are proven to be of a microplastic nature are inert. Many of them do pass through the body. This is not to suggest that it's okay. We can't really take the precautionary principle for something, I guess, when it's so ubiquitous. But the same type of studies, if they had been done in 1950s in London, certainly would have showed an awful lot of soot and other problematic chemicals in people's lungs from the way that we made things. This would have been true in LA in the 80s. And in both cases, we did improve environmental outcomes through regulation and smarter technology. Can the same thing happen for plastics in the future? Maybe. I'd like to think I'm humble enough to know that I can't predict the future in 100 years. But these things we need to be careful how much focus we put on them and extrapolate from them, because we could end up solving the wrong problem or putting too much resources onto something that is maybe better focused elsewhere, right? Like bigger problems to solve. And what I refer people to is a Project Drawdown. There's a very interesting group that lists some of the biggest impact factors in terms of environmental, if not remediation, but impacts on the environment, and their overall carbon footprint and the benefits that we would get by addressing some of them. Plastics are pretty far down the list. It's not to say they're looking at human health in all of them, but it is a factor and a big part of it. So while we need to be aware and continue the studies and look for causation versus correlation, it's not the only thing. And I just think we need to not over focus on it.
Yeah, the thing I want to add on is I would agree that we would not be able to get rid of plastics totally. I mean, there was a reason we invented that. For example, it's much lighter, it protect the food, enhance the barrier. So when we consume them, we can avoid like it has the antimicrobial activities, things like that. However, I do think, and I want to point out though, according to literature, what makes microplastic or nanoplastic hazardous is actually mostly the plastic additives embedded into the polymeric structure. The polymer itself is relatively safe. Saying that, I do think it would be worthwhile to look into how can we design safer chemicals to replace those additives. So for example, the phthalates is a good example that researchers has been studying and trying to replace the phthalates with safer design used in PVC, in many different plastics. Another thing I would agree with Connor here is what can we do to potentially filter or vet the major microplastic production. For example, I believe in California, a few years ago, they passed a law to implement or enact locally to implement filtered or to improve their laundry system. So any water released from the launder should be filtered out the microfibers before released into the sewage system. So that's something we can consider because indeed microfiber is a major release of micro plastic particles. Similarly, for the tire system, perhaps the tire manufacturer can go back and redesign their tire system. Can we make them compostable? So even though they are being released as particle, eventually, if we know they will be composted in 2 years in a reasonable amount of time, then the issues may be less. Or maybe we can implement some sort of filters. So those are like engineering devices that we can help as a plastic engineer, I suppose. One last thing is, as far as I'm aware of, NIOSH, an institute under NIH, they in the past 2 years or so, they do have course looking into the potential health effect of microplastic into human health. I do think it's still an ongoing issue, and I would emphasize again, I worry more about the additives because they are the small molecules that could more easily interact with human body. And how can we design a safer one, a better one? That would still remain as an R&D question.
Really good point. Well, I think we're at time, and I want to thank you all for your contributions to this discussion, and Dr. Chen for your able facilitating of the conversation. So I'll just say to all the attendees who are still on the line that this has been recorded and that all registrants for the webinar will receive a link to the recording for future viewing. So thank you all once again and have a wonderful rest of your day.
Thank you.
Thank
Thanks,
you.
John. Bye-bye.
Bye-bye.